In this video, I'd like to look at Mathematica or Wolfram Cloud's solve and substitute, and also sort of naming the equations that I am solving and substituting into. So I chose as an example problem a sort of simple one-dimensional mechanics problem from sort of intro physics course, sort of two particles in one dimension where momentum and energy are both conserved. So I will have two equations, one for conservation of momentum and the other one for conservation of energy. And then I will solve one of them, substitute it into the other, and then solve that. Okay. So sort of in some, I'll explain what's going on, though it doesn't necessarily matter if you're just interested in solving and substituting. But I have two masses, M1 and M2. They initially have velocities U1 and U2. And then there is some collision among the two, presumably. And then after that collision, M1 then has a velocity of V1 and M2 a velocity of V2. So this first equation is the mass times the velocity of the one and the mass times the velocity of the other before, and that total momentum, system momentum, should be equal to the momentum after. Okay, now a little Mathematica explanation here. The equation, the sort of physics mathematical equation, has two equals, and then I have another equal out front, and this is just like assigning or naming. So just I'm naming this equation one. And when I enter it, it will also get a name of, like, you know, since it's the first one, probably out one, unless I sort of mess with the order somehow. And what I used to always do is just sort of solve the equations with the sort of given name, the name given by Mathematica, out one and out two. And what I was finding is people were sort of following what I was doing, but if they made different mistakes than the mistakes I made, or if they had something previously going on in Mathematica and completely closed it, then their numbers, their ins and outs were different than mine, and they might sort of follow a little too blindly. So I've sort of started thinking about, does naming them, which is sort of an extra step, but it might solve the problem of now people will be able to sort of follow what I do more exactly, because if I name it, then I've controlled the name, and I don't have to worry about, is, you know, my out three the same as their out three? They don't have to worry about it. I don't have to worry about it. They can just use, if they choose the same names as I do, then they will be able to do what I do, and it should work no matter where they are in their sort of memory history of Mathematica. Okay, so let's shift enter this. And so I can refer to this equation now as out one, but I can also refer to it as EQ1. And note that I have spaces. So sometimes I will use an asterisk, M1 asterisk Q1 for multiplication, but you don't need to do that in Mathematica. You can just have a space and the multiplication is implied, and that's what I've done here. But the space is important. If I just had M1 right next to U1, M1 U1, it would think that was the name of some variable. Okay, so again, the equal is the like equality of an equation. The single equal is just sort of a naming, and just there's a colon equal that sort of comes up when you're like defining functions. Okay, that won't appear in this example, but it is another place where one sees a different variation of equal. Okay, my equation 2, EQ2, is conservation of energy, kinetic. So I have kinetic energy, 1/2 mv squared. So it's the mass times the velocity squared. I just used caret notation divided by 2. They're all divided by 2, so I could have factored that out, but I wanted to have it sort of familiar form. And so the kinetic energy of 1 and the kinetic energy of 2 before, using the u velocities, equals the kinetic energy of 1 and plus the kinetic energy of 2 after using these. So I'm entering that. Shift enter. Okay, so now I have my 2 equations. And I'm going to sort of imagine a scenario where I know the masses and I know the before values, and I want to find the after values, the V's. So I'm going to solve the simpler equation, the momentum equation, for the second velocity and substitute that in. And so I'm going to solve equation 1 for V2. And then I decided that I also wanted to name the solution. I didn't quite know what to call it, but I called it EQ1V2, the sort of equation 1 solved for V2. I don't know, just making up some notation. But so I'm using solve, I'm solving an equation, I'm solving it for a variable in that equation. And shift enter. Okay. Now I've solved, here is this first equation, solve for V2. So take M1, V1 to the other side and divide by M2, that makes sense. And then it is equations. You might solve more than one equation. You have multiple variables. So, but this is just saying this is the solution for a single variable, a single solution for a single variable. So that's the sort of double curly bracket notation that I'm solving. I could have solved for multiple variables. I solve for 1. I could have multiple solutions. I have 1. So that's why double curlies with just sort of one thing. So this is V2 in terms of the other variables. Okay. So now I'm going to, I just called it, again, I'm still sort of giving things names. So I'm going to take, this is my substitution now. I'm going to solve and substitute, and then maybe solve again. I'm taking equation 2, which was the energy equation, and slash dot, that is substitute. So I'm going to substitute this solution I have. For equation 1, I'm going to substitute that in, and then I've decided to I solved it for V2, but we see in this other equation that V2 is squared. So I've decided then I would expand it and then simplify it. And I could probably get away with just simplify, but that's what I decided to do, just to sort of push it to expand it and then simplify it. It's probably unnecessary. Mathematica is pretty smart. And then I decided once again in this approach to name it. So I named it combo for the 2 equations combined. So I'm doing a shift enter of that. Okay, and now I have this new equation with the solution to the momentum equation substituted into the energy equation. So I've gotten rid of V2, and now I want to solve for V1. So that's what I'm going to do next. I'm going to take what I called combo. And again, I could be working with the out numbers, but what I was finding is people who are following me had different numbers and were getting confused. So I called it combo. And I'm going to solve that for V1. Shift enter. And now we see that I'm solving it for a single variable, but now there are two solutions. It's a quadratic formula now. The velocities, there were velocities times each other here. So that was, it's a quadratic formula in V1. And so we're expecting two solutions. So we're getting two solutions here. And one of them is if V1 is equal to U1, and then if I solve for the V2, then correspondingly V2 would be U2 in this solution. And that is the implying that sort of almost that like a collision didn't happen, that they just sort of like passed each other in the night and just sort of carried on as they were. And then here's the solution of, the velocity changing, an actual collision occurred. But, okay. So again, the equal of equations was double equal. If we choose to, we can name equations or assign names to things with a single equal. Solve can solve an equation for a variable, and then this slash dot is substitute. So we can substitute a result for one equation into another equation and then solve again. Okay, that's what I wanted to show you. Thanks much for your attention.